it's Presley at ActOutGames.com here, and today we're going to the science co-op again. So we need eye protection. I don't know it's about that, but we do need eye protection, so I'll see you there.
Weeks ago, we talked about if atoms and air, and if air has mass. And we asked some questions about if you blew up a balloon, does it have more mass before it's blown up or after it's blown up? And we couldn't quite agree on the answer to that question. Everybody had some different ideas. And so today what we're going to do is we have this bottle, and it's empty, right?
No.
There's water in it.
Well, there's some water. You're right. There's some water in there, and what else is in there?
Air.
Some air. Okay. And we're going to put this lid on it. Okay. And I want everybody to take a second now. I'm going to give you a piece of paper. And I want you to fold it in half.
Okay.
All right. And on the left side of it, I want you to draw a picture of what you think this bottle looks like if you could see atoms. If you could see what was floating around in this bottle, what would it look like? What do you think?
Your shelf. They're kind of happy. But I'm just gonna draw them happy for now. Okay. And then there's
Now, here's what we're going to do. I'm going to take this bottle. I'm going to turn on our scale.
now I'm drawing
All right.
drops all over it.
And I'm going to weigh this. All right. Who can tell me what it says?
It says 72.1 grams.
72.1 grams. This thing, you know what this thing does?
It pumps air into it.
It pumps air into it. So I want everybody to push it 20 times.
Both. I don't know how to count.
1, 2, 3, 4, 5, Hey, 6, you 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20.
So is it going to weigh more or less or
More.
the same?
It's gonna break the scale.
Is it going to weigh more
It's gonna break
or
holes.
less
No, it's
or the
gonna
same?
blow up
Who
the
thinks
world.
it's going to weigh the same?
Not me.
Not
Who thinks
me.
it's going to weigh less?
Not me.
Who thinks it's going to weigh more?
Me.
Wait, 73.5.
Something.
More.
It weighs a lot more, huh? Not a lot more, because a gram isn't really that much more. All of that air that we put in there, it weighs something, but it only weighs about this, as much as this tissue. But look at how much space it's taking up. So we put some vinegar in here, you guys, look. Now, we're going to put the baking soda. So what we just did, Helen, what we just did was an experiment in an open system. So what could happen in an open system?
It would spill out.
Spills. Yeah.
Could spill.
Gases can float away, right? So now we're going to create a closed
Safety first.
system. More or less or the same?
Same.
Not the same as last time. The same as it was. 40.1. 40.3.
0.0 pounds.
Something.
So we lost 0.1 grams, but, well, see, now it says 39.9. So more or less the same, right?
Yeah.
Okay, now I'm going to take the lid off for a second. What's going to happen?
It's gonna go fizz up.
Is it going to fizz out?
No, it's gonna
It's gonna do the flop. It's gonna go.
Yeah, it's gonna go.
How high it is, or how?
It's gonna.
Okay,
It's
so
gonna go like.
listen. 39.7.
Less.
Yeah, so,
Less.
yeah. So what happens when the baking soda and the vinegar mix together?
They go one from one side of the periodic table and one from the other side of the periodic table, and they react together and then they blow up.
Still salt.
Yeah.
Yeah.
It's still salt, but
It is.
it's dissolving.
So that's a physical change. The only thing that changes about it is the way it looks. Baking soda into the vinegar, is it still baking soda?
Yeah.
It's not. It comes apart, its atoms come apart and hook up with atoms in the vinegar to make a new kind of molecule that's a gas that floats away. So it's a chemical change. Does that make sense?
Yes.
So we'll talk some more about chemical changes next week. Okay? And what the molecules look like when we're doing chemical changes versus physical changes. Does that sound good?